In September of 2013, a physicist named Don Gurnett stood in front of a room full of reporters at a NASA press conference and did something that sounds almost impossible. He played a sound, a real, audible sound captured by a spacecraft that was, at that exact moment, farther from Earth than any human-made object had ever traveled, sitting in a region of space no instrument had ever occupied before. And the strangest part isn't that he played it. It's what that sound actually was, because in the purest, most literal sense, before that moment, no human being in the entire history of our species had ever heard it. This is the true story of how Voyager 1 let us listen to interstellar space for the first time, what that sound actually is, and why scientists are still listening for it today, more than a decade later, from a spacecraft that keeps drifting farther into the dark with every passing year. Every detail in this video is drawn directly from NASA's own published statements, and the scientist who actually made the discovery, not exaggeration, not embellishment, just the genuinely strange reality of a sound that technically shouldn't be able to exist at all. Let's start with something that might seem like it contradicts the entire premise of this video, because it's important to get right. Space is a vacuum. There's no air, no water, no medium of any kind to carry sound waves the way sound normally travels here on Earth, vibrating through molecules of gas that bump into each other in a chain reaction until they reach your eardrum. In the strictest possible sense, nothing in the emptiness of space can make a sound the way we normally think about sound. NASA has been careful and consistent about saying exactly that, in their own words, that the plasma wave instrument on Voyager 1 does not, strictly speaking, detect sound at all. The answer lies in a specific piece of hardware built into Voyager 1 back in the 1970s, called the Plasma Wave Subsystem. It's not a microphone, and it was never meant to be one. It consists of two long, thin antennas, sometimes nicknamed the spacecraft's bunny ears, extending about 30 feet out behind Voyager 1's main body, giving the instrument a wide enough reach to properly sense the extremely faint electrical signals it was designed to detect. Rather than detecting actual air pressure waves, these antennas are designed to sense something entirely different, oscillations in the electrons that make up plasma, the ionized, electrically charged gas that fills the space between stars and planets throughout our solar system and beyond, sometimes called the fourth state of matter because it behaves so differently from ordinary solids, liquids, and gases. When plasma gets disturbed, whether by a shock wave, a change in density, or some other physical event, the electrons within it vibrate at specific, measurable frequencies, oscillating back and forth in a way that carries real, physical information about the plasma's own properties. Voyager 1's instrument was specifically engineered to detect exactly that kind of vibration, a piece of scientific hardware whose original designers almost certainly never imagined it would still be operating, and still making headlines, nearly 50 years after launch. Here's the part that makes this genuinely remarkable rather than just a clever technical trick. Those electron oscillations happen to occur at frequencies that fall within the range of normal human hearing, generally somewhere between a few hundred and a few thousand hertz, almost the exact same range as the ordinary sounds you hear every day. That means scientists can take the raw data recorded by Voyager 1's plasma wave instrument and simply play it back through an ordinary speaker, converting an invisible, inaudible physical phenomenon into something a human ear can genuinely perceive and interpret. As Gurnett himself explained it at the time, the pitch and the frequency of that sound tell scientists directly about the density of the gas surrounding the spacecraft at that exact moment, turning something abstract and invisible into a real, audible signal carrying real, usable scientific information. Now here's where the actual history of this discovery gets interesting, because it didn't happen in real time, the way you might expect from a modern spacecraft. NASA announced in September of 2013 that Voyager 1 had actually left the heliosphere, the vast magnetic bubble inflated around our entire solar system by the constant outward pressure of the solar wind back in August of 2012, more than a year earlier. That delay wasn't due to any uncertainty about the crossing itself. It was because of exactly how slowly information travels back from a spacecraft this far from home. Voyager 1's data at the time was being stored on old-fashioned onboard tape recorders and played back to Earth only every 3 to 6 months. A genuinely strange detail to sit with when you consider that the spacecraft carrying this equipment was, by 2012, already one of the most distant and scientifically significant objects humanity had ever built. Once that data finally arrived, it still took additional time for scientists to properly process and interpret it, sorting through months of accumulated recordings to identify the specific signal that mattered. Gurnett has described the genuine thrill of realizing, well after the fact, that his team was looking at solid evidence the spacecraft had already crossed into an entirely new region of space, one no human instrument had ever directly sampled before, a discovery that had technically already happened a full year before anyone on Earth actually understood what they were looking at. The plasma wave data itself told a clear, unmistakable story once scientists finally examined it closely. While Voyager 1 remained inside the heliosphere, Still surrounded by the relatively thin, rarefied solar wind streaming outward from our sun, the plasma tones the instrument picked up sat at a low pitch, hovering around 300 hertz, a low, steady hum comparable in pitch to a low note on a piano. But once the spacecraft actually crossed into true interstellar space, that pitch jumped noticeably higher, settling into a range between about 2 and 3 kilohertz, a shift scientists explained as reflecting the denser plasma that fills the space between star systems compared to the relatively sparse solar wind found closer to home. That transition in pitch, audible and unmistakable once you know what you're listening for, became a genuine piece of scientific evidence, not just a poetic illustration, confirming that Voyager 1 really had crossed the boundary of our entire solar system. Gurnett himself referred to that shift as the transition music, a phrase that captures something genuinely fitting about the moment, an actual audible change in pitch marking one of the most significant boundaries our species has ever physically crossed. Scientists identified 2 separate, clearly documented instances of these interstellar tones in Voyager 1's data, one stretching from October to November of 2012, and a second from April to May of 2013. Both events, researchers determined, happened shortly after massive eruptions of material from the sun, called coronal mass ejections, sent shock waves rippling outward through the solar system and eventually crashing into the surrounding interstellar plasma far beyond Voyager 1's position. A journey those shock waves take more than a year to complete, given the sheer distance involved. Gurnett suggested at the time that these shock fronts, born from violent activity happening back at our own sun, were physically disturbing the plasma around the distant spacecraft, essentially ringing it like a bell and producing exactly the kind of audible tone his team had captured and could now actually play back for anyone willing to listen. A genuinely poetic way of describing something that started as an ordinary eruption on the surface of our own star and ended, more than a year and billions of miles later, as a measurable audible tone recorded by a machine sitting outside the entire solar system. What makes this discovery worth returning to more than a decade later is that Voyager 1 never actually stopped listening. In the years since that first historic recording, the spacecraft's plasma wave instrument has continued detecting these momentary whistles at irregular intervals, an ongoing thread of the exact same phenomenon Gurnett first identified back in 2013. Then, starting in 2017, something changed in a way that genuinely surprised the scientists studying the data. Rather than the occasional isolated bursts scientists had grown accustomed to interpreting, tied to specific solar eruptions reaching the spacecraft's location, Voyager 1 began detecting something closer to a persistent, ongoing hum, a continuous signal rather than a series of momentary events. Researchers eventually published their findings in the peer-reviewed journal Nature Astronomy, describing interstellar space itself as turbulent, structured, and dynamic across scales ranging from mere meters up to millions of miles, a genuinely different picture than the calm, largely featureless void earlier models had predicted this region of space should be. This ongoing signal has now been tracked continuously across a stretch of interstellar space stretching more than 900 million miles wide, roughly 10 times the entire distance between the Earth and the Sun, giving scientists something they'd never had before: a continuous, evolving picture of interstellar plasma density rather than a handful of scattered, isolated snapshots. There's a genuine, still unresolved scientific question buried inside that persistent hum, one that researchers have not yet been able to fully answer. The signal could be caused by what's called thermally excited plasma oscillations, essentially the natural ambient vibration of plasma particles interacting with their surroundings, a phenomenon that would fit comfortably within existing physical models of interstellar space. Or it could be something scientists call quasi-thermal noise, a distinct physical mechanism that would require meaningfully revising how researchers currently understand and model the interstellar medium. Distinguishing between those two explanations requires either more data from Voyager 1 itself, or an entirely new mission specifically designed and equipped to study interstellar space directly, and no such mission currently exists or is funded. If it were greenlit and launched today, it wouldn't reach the heliopause the boundary Voyager 1 crossed back in 2012, for at least another 25 years. That's really what makes this specific sound so genuinely precious, in a way that goes beyond simple scientific curiosity. Voyager 1 remains, to this day, the only instrument our species has ever placed directly inside interstellar space, and its plasma wave instrument remains the only tool we have that can actually let a human being listen in real, audible sound to conditions in that region as they exist right now, rather than reconstructing them indirectly through distant, secondhand observation. Every other measurement humanity has ever made about interstellar space has come from telescopes and instruments sitting safely inside our own solar system, inferring conditions far beyond our reach through models, calculations, and educated extrapolation. Voyager 1's recordings are different. They're direct. They're immediate. They are, in the most literal sense possible, The actual sound of a place none of us will ever visit ourselves, translated just enough to become something our own ears can process and understand. There's something worth sitting with in the fact that this entire discovery almost slipped past unnoticed for over a year, buried inside slow, infrequent data transmissions from a spacecraft too far away for anyone to check on it in anything resembling real time. And there's something equally worth sitting with in the fact that more than a decade after that first announcement, Voyager 1 is still out there, still listening, still occasionally catching new tones and new signals that scientists are still working to fully understand. The spacecraft that first let us hear interstellar space in 2013 is the exact same spacecraft currently approaching a historic distance of a full light day from Earth later this year, still running on dwindling power, still carrying an instrument built in the 1970s that continues to give us something no other tool in human history ever has, a genuine audible connection to a region of the universe that exists entirely outside everything we've ever called home. So here's what I actually want you to take away from all of this. That sound Don Gurnett played at a press conference back in 2013 wasn't a metaphor, and it wasn't a dramatized sound effect added for a documentary. It was real data, captured by real hardware, converted just enough to let a human ear actually perceive something that had never been heard by anyone in the entire history of our species, a direct signal from the space between the stars. And Voyager 1 is still listening right now, this very moment, still occasionally catching new whistles and new tones in a persistent hum that scientists still don't fully understand, from a region of space that remains, to this day, almost entirely unexplored by anything humanity has ever built. There's a certain humility built into this whole story that I think is worth sitting with for a moment. This wasn't a triumphant, instantaneous discovery announced the moment it happened. It was a quiet, delayed realization pieced together from months-old tape recordings by a small team of scientists patiently sorting through data long after the actual historic moment had already passed unnoticed. And even now, more than a decade later, the full picture still isn't complete. Nobody can yet say with certainty what's actually producing the persistent hum Voyager 1 has been detecting since 2017, whether it's an entirely ordinary physical process or something that would force a genuine revision of how we understand the space between stars. That kind of open-ended uncertainty doesn't usually make for tidy headlines, but it's a far more honest picture of how real scientific discovery actually unfolds, one delayed, painstaking data review at a time. If you want to actually hear this sound for yourself, NASA has made the original 2013 recording publicly available, and I genuinely encourage you to go listen to it, because there's something different about hearing it rather than just reading about it. Subscribe and turn on notifications if you want to know what Voyager 1 catches next, because after everything this instrument has already picked up, I don't think we've heard the last surprising thing it has to tell us. And drop a comment telling me what you think that persistent, unexplained hum turns out to be, because scientists still genuinely don't know, and I have a feeling the real answer is going to be stranger than anything we could guess.